Okay, so we're recording now, guys. And so what we just reviewed was the quadratic formula. And once again, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. And we talked about the importance of order of operations. If you're punching this into your calculator and you want a decimal approximation, make sure you tell it this is the numerator. And how do you tell your calculator that? You group it. This is the denominator. Make sure you tell your calculator what you mean to tell it. And this A, B, and C comes from when we have our quadratic in standard form. A is the coefficient of your square term. B is the coefficient of your linear term, and C is your constant. So we've started plugging it in here. And so we did negative b, which is the opposite of b, plus or minus b squared. And since 5 was such a simple number, I went ahead and squared it. 5 squared is 25. Minus 4 times 1 times 2. Oh, that's not 2. A is 1. 4ac. No, C is 2. C is 2. It was right. All over 2 times A. Okay, so this was the part we'd handle first. 25 minus 8. And 25 minus 8 is 17. And so this is what we would get as our answer. X equals negative 5 plus or minus root 17 over 2. So we know that's really two solutions. The first one solution is negative 5 plus the square root of 17 over 2. And the other solution is negative 5 minus the square root of 17 over 2. So that's what that plus or minus is. Kind of a shortcut way to write both of these, right?
So we don't have to write the decimals?
You do not. You do not. No. Alright, so this next one. So if we solve this one, we get x equals negative b, which is positive 3, plus or minus b squared. Now when I square negative 3, I get a positive 9. Because a negative times a negative is a positive. Minus 4 times a times c, all over 2 times a. So what we get is 3 plus or minus the square root of. Alright, so this is 9 minus 16, which is negative 7. Now, last year when we got a negative under the radical, we just said no real roots, no real solutions. But we know what to do with this now. We can take the square root of a negative. So this is what I would expect now. So we're taking it one step further. Yeah. So that would be our solution. Yes.
So the bottom, oh, that's over 2. I'm just kidding.
Okay, so if we come back up here, classify your solutions above as real or complex. Well, this is real, and this is complex. Now, if it's real, classify it as rational or irrational. Let's remind ourselves what rational means. Okay? This is a number, and that's not just a hashtag, it also means number, that can be written as a fraction of integers. So, are these integer numbers? Are all these integer? No, it's not. Square root of 17 is not an integer, is it? So, is this rational? No. But if it's real and it's not rational, then it has to be irrational. So, what falls into the irrational set? That would be square roots that we don't know, like square root of 2. It would be also numbers like pi, e. Okay. All right. And if we classify it as complex, then it's not going to be rational or irrational because that's part of the set of real numbers. Okay. Yes.
When will we be issued calculators?
Tomorrow. Yeah. that was a really good question. Mary asked, when will we be issued calculators? Those of you that turn in a calculator form will receive your calculators tomorrow. And those of you that were planning to use your own calculator, make sure you bring those graphing calculators to class starting tomorrow. If there's anybody that did not take a calculator form to start with that now needs one, those are over there on that stool. And if you'll bring that back to me tomorrow, I can get you one. Okay? Alright. So let's start here, because this is today. If we look at this polynomial function, f of x equals x cubed minus 8x minus 3, it's not a quadratic, is it? We did learn how to factor some cubics though, didn't we? We learned how to factor a sum of cubes and a difference of cubes. Does this polynomial function fall into that category? No. So right now, do we know how to factor this over the set of integers? No, we don't. Okay? Now, we just did quadratic formula, so could we use the quadratic formula to find the roots of this function? Eventually, but not to start with, because it's a quadratic formula. And so what do we use it on? Quadratics. And what kind of polynomial is this right now? Cubic. Okay, so the answer would be no. This is a cubic polynomial. Are you writing this down, gentlemen that are talking? Not a quadratic. Okay, so how can we find all the roots of this function then? If it doesn't factor and it's not a quadratic, then guess what we're going to use? The rational root theorem. So we're going to say using the rational root theorem. Alright, so let's kind of break down this name. Rational. Rational means can be written as a fraction. Root. We know what roots are. We've already been finding roots and factors, haven't we? Of equations. So, man. It erased everything. Even the stuff I didn't mean it to. Okay. So, here's your definition, guys. And take a minute to write down this definition. And then we're going to work through that example that we just said we don't know how to do yet. And there we go. Now it's all gone. Okay, so please write down this definition.
What's the important part that I have to read, where I have to read all of it? Can you just sum it up for me, basically? I don't read all this.
I think this is the first definition I've asked you to write all year, but
Yeah.
this part right here that's bulleted is the important part.
Alright,
Why does Sam
Yeah.
always like
I'll do it.
buy stuff like she's the girl
Should be
she wanna shop?
It won't take this. Oh, I showed a piece of plastic.
Stevens?
It's
You got curly
great.
hair?
Oh, that's a dog and a duck in his mouth.
It's really curly. It's not.
Oh, pee over Q. Everybody probably already figured that out. Q. Got my piece. Yeah. Yeah. I don't get it. Yeah. Yeah. I don't really get that.
Okay.
Oh no.
So let's talk about the specifics of this definition. All right. So it says if polynomial p of x. Now this is function notation, guys. And since we're talking about a polynomial, instead of using f of x, they threw out the letter p because it relates to polynomial. So for any polynomial function p of x has integer coefficients, then every rational root of the polynomial equation, p of x equals 0, can be written in this form, plus or minus p over q, where p is a factor of the constant term, and q is a factor of the leading coefficient. Okay, so let's think about that equation, and you guys don't have to write it again because you can still see it on your paper. F of x equals x cubed minus 8x minus 3. Is this a polynomial function? Yeah, it has integer coefficients, and we learned from our game the other day, it also has to have positive integer exponents. Can't have negative integer exponents, right? Like that one back there had negative integer exponent, which kept it from being a polynomial function. Okay, so here's our polynomial function. And it asks us to look at two different things. It says, all right, you need to pay attention to the constant, because that's p. So this is our p, isn't it? Okay? And then you also need to pay attention to the leading coefficient, which is an understood 1, isn't it? And that gives us our q. So 3 is not our only p, because p is the factors of that constant term. So p is the factors of -3. And q represents the factors of +1.
What do you mean by factors?
Things you can multiply and get that number. So if I said, what are the factors of 6? You would say 1 and 6 and 2 and 3. Because those are things you can multiply and get 6. Okay? Alright, so if I were to do plus or minus p over q, what are all the factors that can give us 3? Well, 1 and 3. Because 1 times -3 is 3, and -1 times 3. So we do the plus or minus. Okay? What are all of our factors of q? How can we multiply to get +1? 1. Okay, so this list is pretty simple because I'm just dividing by 1. So it's plus or minus 1 and plus or minus 3.
What happened to the one?
So these are all the possible rational roots. And possible is our key word here because they all don't work.
Is that a comma?
What do you mean possible? They all don't work. And why are they possible if they don't work?
Where's a comma? This dot right there? Yeah, it's a comma. Okay, so your question was, why are they just possible? This rational root theorem doesn't tell you that all of these will be roots. It tells you which ones could possibly be roots. Now, how do we figure out which ones are roots? What did we learn last week? about if we have something that's a root, how do we test to see if it actually is a root?
Plug in the remainder.
The remainder theorem. Okay, so this is where we have to go back to what we learned last week. And if we plug in +1 and we get out 0, then it's a root. Okay, so let's plug in +1. +1 cubed minus 8 times 1 minus 3. 1 minus 8 is -7. And -7 minus 3 is -10. Is +1 a root? No, because I didn't get out 0. Alright, next one. Okay, so -1 cubed is -1. Plus 8 is 7. Minus 3 is 4. Is -1 a root? No. Okay, +3. Okay, let's think about that question. Ryan posed a very good question. He said, is it possible that none of them are roots? Okay. It is. We do know we have to have at least one root though. It may not be rational, but we know we have to have one. And the reason we know we have to have one is because this is an odd degree function. So what do we know about the ends of an odd degree function? They go opposite directions, which tells us at some point this function has to cross the x-axis, doesn't it? So there has to be a root because it has to cross the x-axis for the end behavior to be opposites. Now, this one does have a rational root, and it's actually this one, because 27 minus 24 is 3, minus 3 is 0. Now, if it is a cubic function, and I find one rational root, gentlemen, either hush or leave. If I find one rational root, I'm good. Because if I know one rational root, I can do synthetic division with this one. This one is actually 3. I don't know why I wrote a 1 here. This one is 3. So what we do now with the one root we know works is synthetic division. We know 3 is a root. So the root goes on the table. Now if I gave you a factor, we have to do the opposite. But if you've got a root, do you have to do the opposite? No. Okay. My leading coefficient is 1. That's my cube term, my cubic term. What is the coefficient of the squared term? 0. Linear term, -8. And then constant.
You get,
Why did you decide to use the 3 to do long division? Is this just part of rational root theorem, or?
No, the rational root theorem, basically the rational root theorem just gives us this. That's all the rational root theorem does, is it gives us our possible rational roots.
Why are we?
And then we had to use the remainder theorem that we learned last week. Okay, so we learned the remainder theorem last week that says if the remainder is 0, then that value is a root. And then we go back to what we learned about synthetic division. If we have a root, we can synthetically divide to find other roots. So we're tying back 2 or 3 things we learned last week with this one new part.
Are we just doing like the different ways to prove that those are possible roots? Like, why are we actually dividing, or are we finding different roots?
We're finding all the factors.
Okay.
We're using the rational root theorem to find all, well, we're not going to write it as factors, all the roots. Okay, so we bring down the first one.
And will all the possible rational roots always, one of them will equal 0?
They will in here.
Okay.
I will make sure one of them works. Okay, so we multiply and we add. We multiply and we add. We multiply and we add. And this better happen. Because if I'm calling 3 a root, my remainder better be 0. That's my check step. Okay, so what I'm left with, I started with a cubic,
So it would be 1.
and now this is a quadratic, isn't it?
Yes.
So I've got x squared plus 3x plus 1. Now I can use quadratic formula.
So you do all that.
Negative b
Wait,
plus or minus the square root of b squared minus 4 times a times c all over 2 times a. We got a lot of rest and came back whining today. That was amazing. How many? 5 different people whined at this point.
I grumbled.
Alright, so 9 minus 4 is 5. Alright, now, these are 2 of our answers. But this is also an answer. My roots are 3. So anything I get here with a remainder of 0 is a root. 3, negative 3 plus root 5 over 2, and negative 3 minus root 5 over 2. So we have 1, 2, 3 answers.
You can't just leave it as plus or minus.
You can. But last period when I left it as plus or minus, none of my class saw all 3. So this period I decided to split it up.
But we took
Certainly, you can write your answer like this. Yes, Mary.
For the all possible rational roots, would you like stop when you find one that's equal to 0, or would you like solve negative 3? Would you do that?
In this case, we stopped because we started with a cubic. So all we needed to do was divide by 1 to end up with a quadratic. If we start with a higher degree polynomial function, such as a quartic, we would have to find 2. And we'll do one of those on the back. Okay. Alright, so my directions say find all roots of the following polynomial functions. So step 1 to finding all the roots is finding all the possible rational roots, because this doesn't factor. It looks like 4-term grouping, it doesn't work. Because if I took an x squared out, I'm left with x plus 5. Is there any way to be left with x plus 5? No. So we can't factor this. And so we have to have another method. And so the first thing we do is find a list of all possible rational roots. And then we test those to see if any of them are possible rational roots. So this is when we do our plus or minus p over q. Okay, this time p is 4. What are all the factors of 4?
2 and 2, 4 and 1.
All right, 2 and 2, 4 and 1. There we go.
We can count. You said we do the calculus, right?
Tomorrow.
Not really.
Yeah, I didn't give you big numbers. 4, 2, 2.
25.
This is the one you get to skip.
Oh, yes.
But how many factors does 25 have, guys? 3.
4.
1 times 25 and 5. It only has 3 factors. It's not a ridiculous number of factors. Okay. All over Q. Now this is our Q. It's an understood 1. What are the factors of 1?
1.
Just 1. So when I divide these, 1 divided by 1, 2 divided by 1, 4 divided by 1, my possible factors are plus or minus 1, plus or minus 2, and plus or minus 4. Okay, this is a cubic. I only have to find one that works. So, f of 1, f of negative 1. Girls, please find f of 1 and f of negative 1. Gentlemen, or I guess I called the wrong girls. Boys, y'all find f of 2 and f of negative 2. Huh?
Because we're hardworking. Yeah,
Oh.
I was testing you to see if you would just man up or if you complain.
A pass on the real man.
So you just plug in one into the x. You plug in that number for x. Makes sense. So what's going to do? 5 times 1 squared.
Ooh, yeah. Alright, ladies, what did we get for 1? 5. Doesn't work, does it? What about negative 1?
Negative 3.
Negative 3. Alright, both ones I assigned the ladies did not work. Gentlemen, what did you get for 2?
-4. Negative 4. Actually, I just like saw it at work.
How about 30? Alright, so that doesn't work. Alright, negative 2.
This one doesn't work either. I just took the answer.
It's 2. Alright, let's try 4.
Oh my gosh, how 4 times 4?
Alright, so 4 would be 64, and then 16 times 5 is 80. And then 12, okay, we don't even need to do it, do we? We just know it's not 0.
Negative.
Okay, so negative 4 better work, or that was really mean of me. So negative 4 is negative 64 plus 80 minus 12, so that's negative 76, so we're at positive 4. Minus 4 is 0, finally.
Wow.
That one worked.
You did that, sorry, just made us do that one last. You did that one.
I was gonna start at -4, then you told me not to.
Alright,
And then you take out the.
it's negative 4, because when we plug negative 4 into this, and you're welcome to use a calculator for that, certainly. Alright, you get out 0. So when we get out 0, this is a root. That's the remainder theorem.
So then you
Wait.
So now negative 4 goes on the table, and I've got 1, 5, 3, negative 4 are my coefficients and my constant. I'm not missing any, so I do not need a 0.
So it doesn't. Wait, what is 4 equal? Doesn't equal 0.
4 does not equal 0. I knew it was a, this is 144 plus 12.
You just put.
It's 152.
Okay.
I knew it wouldn't be anywhere close to 0, so I just said doesn't equal 0.
Maybe 154, you said?
152. Alright, so we bring down, we multiply, we add, we multiply, we add, we multiply, and yes, we get 0. Okay, so this is a quadratic, this is my squared term, this is my x, this is my constant. So when I do the quadratic formula, it's pretty easy. X equals negative b plus or minus the square root of, this is all ones. So wow, this is easy. 1 squared is 1. Minus 4 times 1 times negative 1. all over 2 times 1.
You're gonna have to memorize this quadratic formula.
There's a song.
That'd be,
Yeah.
be a good idea.
Yeah.
Yeah. That's definitely a tool you need. That's a special kind of awesome.
That's good work, guys.
Alright, so here are 2 of our answers. But there's one more. What's my other answer?
Negative.
-4. We can't forget the one that worked over here. Never forget the one that worked to start with.
Whoa, wait a minute.
This is the one we found to start with. It's one of our answers.
So we have 2 answers.
So this is a cubic, and we have 3 answers.
Wait, time out.
Oh, so if it was like 4, then there would be 4 answers?
Sometimes there are.
Sometimes?
You'll discover tomorrow on an activity that sometimes there are. Okay. I've got to go over number 3 before we move on.
How did you get it? Why did you do?
Can you finish? I'll try to answer your question. Go ahead. Okay, you guys, give me all the plus or minus p's over q's for this one.
2, 1.
You're correct. Okay, because my constant is just 2, my numerator is plus or minus 1 and 2, my leading coefficient is just 1, so my possible rational roots, if I ask you to list all possible rational roots, that's it. Plus or minus 1, plus or minus 2. You're done. What's the next step?
Plug in.
Yep, we find f of 1.
Wait, how do you find that? I'm confused on how you find possible.
Come on,
Okay, you take your constant,
Easy.
all the factors of that number go in the numerator. And then you take your leading coefficient, which is an understood 1, and all its factors go in the denominator. Okay, so how many people got excited when they did f of 1 and got 0? Okay, so that one works. Now, on the other problem we could have been done, but this one is a quartic polynomial.
Doesn't have to have it.
So, how many times do we have to divide to get down to a quadratic? Twice. So, how many zeros are we looking for? 2.
Oh, what?
It's not -2. I bet it's 2.
See? I could have done it.
Okay. This is 2. This is not 0.
Aha. So I was right.
This one is 0.
Wait, why are we looking
I
for
was half
2 zeros?
right.
Because it's a quarter.
Okay. So in order to get it down to a quadratic, we're going to have to divide twice. And it doesn't matter the order. So these are our 2 that work for us, right here and right here. So we're going to put 1 on the table. Okay? I've got 1, 4, 2, -5, and -2. I wasn't missing a term, so I do not need a 0.
Oh, you don't do the opposite. So you don't do the opposite of the first, like.
We do the opposite when you have a factor, but if you have the roots, you do not do the opposite.
Not this one, right?
No, like x minus 1 would be.
Correct. Correct. Alright, so we bring down the first one. We multiply, we add. We multiply, we add. We multiply, we add. We multiply, and we get 0.
Well, I just didn't get that.
Check your multiplying and addition.
So then we divide those numbers by -2.
Okay, I got
But now we go from there.
now we work from this step. This is now a cubic. So now we take this, and from that step,
They do synthetic.
we do synthetic again by negative 2.
Order doesn't matter.
You could do negative 2 first and then 1 first, you'll get the same answer.
Yeah, you guys have that. You get 0.
Does it matter which order we use?
It does not matter. As long as your arithmetic is correct, you'll get the exact same bottom line.
So the 0, just like, we don't touch it or anything?
No, the 0 would be the remainder, so it is not part of it. Good point. Alright, so what we're left with here is that quadratic. See, when we work our way back, we have a quadratic. So, negative b, plus or minus square root, plus or minus square root, b squared minus 4ac, b squared minus 4ac, all over 2a, all over 2a. Alright, so that'll give us our other two roots.
Yes.
Negative 3 plus or minus 9 minus 4 is 5. Alright, so there's two of them. But we can't forget the other two. Negative 2 and 1.
Alright, that's not so bad. You not solve that at all?
It's completely solved. I mean, if you want to split this to negative 3 plus root 5 over 2,
I'm gonna end up doing it.
and negative 3 minus root 5 over 2, you're welcome to.
Just whatever.
Alright, so your homework is to finish. You're going to do number 2 at up top, on the top part. You get to skip number 4. And then on the bottom part, you're going to do 1 and 2. So you have 3. That's it. Yeah, that's plenty. Okay, those of you that need to finish up the around the room game, you may come get your form. Now, the 4 that were on the desk are on the door today. Okay? Those of you that do not need any more time with around the room, you may begin your homework. Nobody's going to be sitting around goofing off talking. You're either doing around the room or homework. They're right up there.